The solids are classified as conductors, insulators and semiconductors on the basis of their conductivities. The solids with the conductivities ranging between 10 to the power 4 to the 10 to the power 7 are called as conductors. The good conductors are those metals having conductivities in the order of 10 to the power 7 ohm inverse meter inverse. Insulators are the solids with very low conductivities ranging between 10 to the power minus 20 to 10 to the power minus 10. Whereas the intermediate between these conductors and insulators are the semiconductors, and they have conductivity range from 10 to the power minus 6 to 10 to the power 4. A conductor conducts electricity due to the movement of electrons or ions. The metals conduct electricity because of the movement of mobile or the free electrons present in them, whereas the electrolytes conduct electricity because of the movement of ions present in them. It's interesting to know that how these substances conducts electricity. The molecular orbitals formed by the overlapping of atomic orbitals of metals are so close in energy that these energy levels overlap with one another and they form a band. This band is known as valence band. It is because the valence electrons are present in these bands. The conductivity of metals depends upon the number of valence electrons available per atom. If the valence band is partially filled, or if the valence band overlaps with the higher energy unoccupied conduction band, then the free electrons that are present can flow easily from the valence band to the conduction band under the application of electric field. And this is how the metals shows conductivity. On the other hand, if the gap between the filled valence band and the next higher unoccupied band, that is the conduction band, is large, means the gap between the valence band and the conduction band is larger, electrons cannot jump from valence band to the conduction band. So what will happen? The substance will have small conductivity and it behaves as an insulator. Hope you have understood how the conductors and insulators conduct electricity. What happens with the semiconductors, the ones which are the intermediates between the conductors and insulators? In case of semiconductors, the gap between the valence band and the conduction band is small. As a result, some electrons from the valence band jump into the conduction band and they show some conductivity since the energy gap is small. Now, if we increase the temperature, what will happen? We can send some more electrons from the valence band to the conduction band, and this increases the conductivity. So, I can tell that the electrical conductivity of semiconductors can be increased by increasing the temperature. Examples for these type of semiconductors are silicon and germanium. And these semiconductors are also called as intrinsic semiconductors. The conductivity of these intrinsic semiconductors is too low. As a result, they cannot be used for the practical applications. Somehow, their conductivity has to be increased. So, what can be done to increase the conductivity of intrinsic semiconductors? The conductivity of intrinsic semiconductors can be increased by adding appropriate amount of the electron rich or electron deficient impurity. And this process of adding a suitable type of impurity to enhance the conductivity of intrinsic semiconductor is called as doping. These impurities that are added to the intrinsic semiconductor introduces electronic defects in them and increases the conductivity of intrinsic semiconductors. Now, let us see which are the electron rich impurities and which are the electron deficient impurities that can be added to silicon or germanium to increase their electrical conductivity. Do you know to which group of the periodic table does silicon and germanium belong to? Yes, silicon and germanium belong to group 14 of the periodic table, and they have 4 valence electrons each. In their crystal structure, each atom forms 4 covalent bonds with its neighbors. When the silicon or germanium is doped with a group 15 elements like phosphorus or arsenic, which contains 5 valence electrons. These impurities, that is phosphorus or arsenic, occupy some of the lattice sites in the silicon or germanium crystal when it is added. 4 out of the 5 valence electrons of phosphorus or arsenic are used in the formation of 4 covalent bonds with the 4 neighboring silicon or germanium atoms. What about the 5th electron? The 5th electron is extra and it becomes free. So this delocalized electron is increasing the conductivity of doped silicon or germanium. So what increases the conductivity of intrinsic semiconductor, silicon or germanium? Yes, here the increase in the conductivity is due to the negatively charged electron. Hence, silicon or germanium doped with electron-rich impurity is called as N-type semiconductor. On the other hand, we can dope silicon or germanium with group 13 elements like boron, aluminium or gallium, which contains only 3 valence electrons. Here, an electron is missing for the bond formation. The place where the 4th valence electron is missing is called as electron hole or electron vacancy. An electron from the neighboring atom comes and fills this electron hole. But in doing so, this creates a vacancy for electron at the original position, resulting in the displacement of electron hole in the direction opposite to that of the electron that has filled it. When electric field is applied, electrons would move towards the positively charged plate through electronic holes, but it would appear as if the electron holes are positively charged and are moving towards negatively charged plate. This type of semiconductors are called as p-type semiconductors. These N-type and p-type semiconductors are used in various combinations for making electronic components. Diode is such a combination of N-type and p-type semiconductor, and it is used as a rectifier. Transistors are the devices manufactured by sandwiching a layer of one type of semiconductor between 2 layers of the other type of semiconductors. We have a P layer that is sandwiched between 2 N types called as NPN transistors, and PNP transistors where a N-type layer is sandwiched between 2 P-type layers. These transistors are used to detect or amplify the radio or audio signals. The solar cell is an efficient photodiode that is used for the conversion of light energy into the electrical energy. Gallium arsenide is a semiconductor that has very fast response and have transformed the design of the semiconductor devices. Transition metal oxides show a marked differences in their electrical properties. Titanium oxide, chromium oxide and rhenium oxide behaves like metals. Rhenium oxide resembles metallic copper in terms of its conductivity as well as appearance. Certain other oxides like the oxides of vanadium as well as the oxides of titanium exhibit metallic or insulating properties depending on the temperatures.